Let's look at transformations of exponential functions. It's a topic we've looked at in the past, but we're going to look at it for exponentials. So the exponential function f of x equals bx, so again, notice it's basic, like a parent function, has a domain of negative infinity to infinity and a range of 0 to infinity, a y-intercept of 0, 1, and a horizontal asymptote of y equals 0. So just as a reminder, here's my parent function. Again, this is 0, 1, and this is just basic, and in this case, b is greater than 1. And it's decreasing if b is between 1 and 0. Okay, so again, the y-intercept is the same spot. The horizontal asymptote is, again, for both is a y equals 0. As a reminder, again, if you enter 0, b to the 0th power is 1, for these values of b that we're allowing for the exponential. All right, so here's an example. Graph this function. What is the domain, range, y-intercept, the horizontal asymptote? Okay, so let's kind of go through each one. What is the domain? Well, when I look at this, what am I doing? I am going to be horizontal shifting. This is, again, a vertical stretch by a factor of 2. So the domain is only affected by the x. So shifting it left and right, since the domain is normally negative infinity to infinity, that's not going to be affected at all. So that continues to be infinity to negative infinity. Okay. What about the range? Well, the range normally is from 0 to infinity. And what can alter that? We can alter that if we happen to, for example, vertically shift up or vertically shift down. But we're not vertically shifting anything. We're stretching here. So if we stretch, it's not going to change the range. It's just going to double. In this case, it's going to be doubling all y's. But again, if it's a 0 or value, it's just going to get bigger. But all the other figures remain. So the range, in this case, is going to be 0 to infinity. It's not affected at all. What about the y-intercept? Well, I think it's the easiest thing to do for this scenario is just to enter a 0 for x and then evaluate like so. And then what we're going to have is the following. 2, and again, a quarter is 1/4 to the negative 5th power. So if I apply the negative and leave the 5th alone, what I have is 4 to the 5th power. So that's a huge number, 4 to the 5th power, extremely big. So I'm going to leave it like that. So it's a very big number. So obviously it's off the charts right here. So we're not able to see it at all. But so the y-intercept right now is going to be 0, whatever this number happens to be. And it's big. Okay. What about the horizontal asymptote? Again, right now it's at y equals 0. And again, just like the range, they can only change this if we vertically shift up or vertically shift down. We're not vertically shifting at all. We're stretching, but that's not going to affect the horizontal asymptote. So the horizontal asymptote continues to be y equals 0. Okay. So we got our, parameters here of what this function limits are located. The one point we do have, we can't even grab. So let me then horizontal transform this using the rules. So right now we have at -1, I'm going to get a few points first. And what am I getting a few points for? I'm going to get it for the basic function. So the basic function is going to be, again, 0.25 is a quarter, so 1/4 to the x. So if I enter -1 into this basic function, parent function, I get 4. If I enter 0 I get 1. If I enter 1, I get 1/4. Okay, so I know the function because b is a quarter or between. So again, what you do have here is that b is between 1 and 0. In other words, 1/4 is between these two values. It's going to be a decreasing function. So I'm going to graph and transform these 3 points and see where that takes us. Then we'll do this all in one shot here. So I'm going to first right here for the x's, and on the other side, I'm just going to write for the y's, just doubling it. So again, one thing we can ask is, what do I need to enter here to get a -1 here to get that 4 to come back out? And the answer is going to be 5? No, 4. Yeah, sorry, 4. If I enter 4 here, 4 minus 1 is -1 right there. So really, this first value, another way of thinking about it is, I'm shifting to the right 5 units. Since I'm shifting to the right 5 units, I'm going to add 5 to this, and that gives me, again, the 4, which I mentioned should be in that position. So there's 2 ways of thinking about it. What value do I need to enter this to get a -1 back out? So when I enter to the function, it gives me the 4. The answer is a 4. Or I can think about it as, well, this is a shift to the right 5 units, really adding all the values of x. I get added 5. So I'm going to take the old x, add 5 to it, and again, get the same value. So using that again, I get that 0 goes to 5 and 1 is going to go to 6. Again, if I go back to the other question is, what do I need to enter to get a 1 back out of here? If I enter a 6, 6 minus 5 is a 1. And then 1 goes to 1/4. So I got my x's. Now all I need to do is find my y's. And that's simple enough. This literally says double the y's because this is after the function, then I can literally do what it says to do. The problem with this is prior to the function getting a hold of it. The function being 1/4 to the x power. But once it's done doing what it's going to do, all I need to do is take this value, double it. Take the next value and double that. And take the last value and double that. And now I have my order pairs. Let's just graph them really quick. At 4, there's 4. I have 8. At 0, no, sorry, at 5, gotta be here, 5. Just I get 2. And finally at 6, I get 1/2. So again, this is making sure that this is the 1, so half of that is right there. And I know that it has this shape, so I'm going to come over here and do my best to connect these points. And then again, this is going to be a horizontal asymptote. Will continue to be at y equals 0. So nothing's changing in that scenario. What we've done is shift to the right and vertically stretch. I should give myself more room for this one. Oh, maybe just have to borrow some real estate from above. All right. None of the case, I need to figure out what's my basic function. So the basic, I need a basic exponential, and all I need to do is look at the base and raise that to x. Okay, there's my basic. And I'm going to get a few points on here that are based off of this basic function. So for example, at -2, I got 3 to -2 power. It gives me 1/3 squared, and that gives me 1/9. All right. -1, 3 to -1 power. Again, what I do is flip to make it a positive, and I get 1/3. That's 0, 3 to the 0 power is 1. 1. That's pretty easy. That's 3 and 2, just as easy. 9. So now let's apply. I'm going to apply these transformations all at once. I need to give myself plenty of space here to accomplish this. All right. So Before I can do this, however, remember, looks like right here I am applying both a a horizontal stretch compression and also some shifting going on. So I cannot tackle this as is. So let me write this function one more time, but I'm going to factor that 1/3 out of here. So it would look like this. Factor out 1/3. Inside, again, the exponent is x minus 1. And lastly, am I getting in my own way here? Plus 4. Okay, I'm going to add 4 to this equation. Hopefully I'm not in the way of the graph. But now I see a little more clearly what's happening in the horizontal direction. I am stretching by a factor of 3 and moving to the right by 1. So I'm going to write that here. And what's happening vertically? Well, it looks like 3 things are happening. I'm flipping across the x-axis. I am stretching by a factor of 6, and I'm shifting up by 4. So there's a lot going on here. But I can apply that directly to each y component. All right, so the x is the one we have to treat more carefully. So, for example, where does -2 go? So it looks like -2. Do this so I can separate nice clearly. So -2 gets stretched by a factor of 3, and then I move 1 to the right. So I got -6. Yeah, -6 plus 1 is -5. Good. How about -1? -1 times 3 plus 1. I don't know why I'm having a hard time, but I am. -2. Okay. 0 times 3 plus 1. I got 3 upstairs. 1. 1. 1 times 3 plus 1, that's 4. And finally, 2 times 3 plus 1, that's 7. Okay, so I got those components out of the way. Let's tackle the y's. I got 1/9 here. So I'm going to multiply the y's times -6. So -6 times 1/9 plus the 4. Okay, I can reduce that down a bit. 6 divide by 3, divide by 3. So what do I get? -2/3 plus 4. And then if I apply a little arithmetic, I don't know if you remember how to write a complex or a mixed number as a improper fraction, but you do 3 times 4 is 12, add what the numerator is. So if I add -2, I get 10. So this is really 10, and then use that denominator, 10/3, or 10 and 1/3. So the first point on this graph here, because I'm anxious, -1 and 10/3 is sitting, no, sorry, yeah, -5 and 10/3. This is 3 and 1/3. So 1, 2, 3, yep, 4, 5. Okay, 3 and 1/3, 5, 3 and 1/3. So about right there. There's that point. -5 and 3 and 1/3. What about this next point? -6 and 1/3. Okay. And plus 4 again. So that's not too bad. 3 divided by 6 is 2, -2 here. So -2 plus 4 is 2. So this point here is -2. 1, 2, -2, and +2. And again, I want to be careful, make sure it's making sense. I think so. I think I'm liking this. Okay, and the next point here is going to be the 1. So -6 times 1 plus 4, that's going to give me -2. So I got the point now, 1, -2. 1, 2. It's right there. Great. Great, 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 great. Looking good. Now I'm going to apply, this is a 4, a little more legible. -6 times 3 plus 4. So that's going to get a little more ridiculous. Maybe I'm going to stop here. -3, 18, -18 plus 4 is -14. and 4, 4, negative 14. Oh, I do have room. Here's 4 and negative 14, 10, 11, 12, 13, 14. There is my negative 14. Looks like I'm going to have to just, yep, right there. Okay, I'm going to stop right there. And I can connect that and I get a pretty good idea of what this graph looks like. All right, there it is. Great. So now let's just talk a little bit about the domain. So how has the domain of this changed? Domain, g of x domain. Well, the parent one is all real numbers. So what have I done? Well, I have stretched, I have shifted, but that's like, again, this one has a domain of negative infinity to infinity. So shifting or stretching doesn't change that. So the domain of this continues to be all real numbers, negative infinity to infinity. Okay, what about the range? G of x range. Well, this has changed because this one, the range, is 0 to infinity in the original. And this is an increasing function. Again, graph of the parent is just this. So again, 0 to infinity makes sense, but the y's have gone a big transformation. What's this happened? Well, first of all, it's been flipped upside down across this axis. So now the range went from 0 to positive infinity to 0 to negative infinity. It also has been stretched, but doing that does nothing, as stretching really doesn't do anything at all. It just makes the y's, but it includes everything. For example, if I take negative or 6 times 0, you still get 0. So the range hasn't changed, but it has changed because I've multiplied it by a negative. So now the range is negative 0 to negative infinity instead, or negative infinity to 0, to state it better. And then what's happened? Well, I've added 4. So really, if I look at now how the range has changed, let me actually say those things. So I've taken negative 6 times 0, and then I'm adding a 4. And what about to infinity? Well, this is kind of be a silly thing, but I'm going to do it anyway. This is obviously this is not right. You cannot take negative 6 times infinity. I'm just joshing here a little bit. But it is doing something. Obviously, adding 4 to infinity does nothing. Multiplying 6 times infinity does nothing. But negating all the output that was here before does do something. So the range really has gone to the following. It's gone from negative infinity to, and now this is an actual point that I can actually do mathematics. Negative 6 times 0 is, of course, 0, but I add 4, and I get the following. So the range has moved to that position. Okay, because again, I flipped and you can see that. I mean, here's 3, this is 4, and it looks like, okay, I kind of drew this arrow, but now I'm seeing that as far as the horizontal asymptote, what I call the horizontal asymptote, where has it gone to? Well, now it's at y, and really it's that edge. Before it was at 0. Why? Because again, if I look at the picture, well, if I look at the picture, let's do here. Here is the horizontal asymptote right there, but I flipped it, shifted it up. So now the horizontal asymptote is at 4. So if I were to graph here, there is a horizontal asymptote right there. So in fact, I didn't draw this very good then, because the arrow's not going that way. And this is curving a lot more than I made it sound like. What about this one? Again, the horizontal, this one, nothing changed. The horizontal asymptote continued to be this position because I didn't shift up nor down, but this one did get shifted by 4. So this one
has a problem, that well, not a problem, but it has moved the horizontal asymptote to now y equals 4, plus flipped it upside down.